Hi, Chris Kuzmal here. I'm going to be talking about some binary tree code that doesn't have a precise place where it belongs, but some basic helper methods that I put in off screen, I need to at least mention and describe. So most of them are pretty straightforward. Uh, Within Node, I created the method called child count. And all it does is it gives the number of children that a given node has, which is just by default 0. But if it has a left child that's not null, then it increases that value by 1. And if it has a right child that's not null, it increases the value by yet another. And as a result, that counts the number of children that our binary tree node has. I think that's straightforward, but I hadn't actually shown that. And that's part of the reason I implemented it off screen was I just didn't feel like it had a place. And it doesn't have a specific place to talk about. PrintWalk is a method that is useful for printing out an entire tree. And from a particular node, what you can do is if your left child is not null, you'll invoke printWalk recursively on that left child. Then you'll print your own key, or really you could print anything you want concerning this node. And then you're going to recursively invoke the method on right child. Always, of course, only if your children on each side are not null. And so that's really handy. That's one of the first methods in Corman, Lysis, and Revest in the area in the chapter on binary search trees. And I didn't bring it up because, well, again, it didn't have a really clear place, but it is pretty handy as a utility method. Also, if we go to the binary tree class itself, there's some methods. On line 24, actually, from prior work, I'm not sure it's going to be line 24 for you, but inside of the insert method, I did not have what's here on line 24. I forgot to set the parent for the new node. And that's not detected in our test cases until we do somewhat more involved things. We're searching up, we're using the parents of a node. It turns out after having done a certain kind of insertions. And so you need to set the parent here. And I did not have this line of code before. So if you wrote insert following what I did, you need to make that change in order to make it so that it works. And also there's a couple of other methods about that I use. And really I could be more efficient. Childless here is the binary search trees helper method that does much the same as the child count method that is in Node. And it does the exact same computation using slightly different logic. And it just tells you whether or not a node is childless. And similarly, one child, whether or not a node has exactly one child. Again, like I said, I probably should and could use the child count method from Node, but I wrote the child count method after I wrote childless and one child. So what can I tell you? The last method I want to talk about is scrubParent. What scrubParent does is for a given node, it makes it so the parent of that node no longer points to it. Okay. Of course, if the node in question you're doing that to is null, you don't need to do anything. If the parent node is null, then you set the root to null, because if the parent node is null, that implies that A itself is the root. And so you need to transform the root into null. Finally, you do the part that's most intuitively obvious, and that is if you're the right child, then you set the right child to null. That is, say, if A is the right child, you set the right child of the parent to null. And if A is not the right child, then you set the left child of the parent of A to null. So lines 85 and 86 are what we think of intuitively when we think of scrubbing the parent, but all this other logic is there to account for cases that somewhat unusual cases where the node being removed is the root, or where the node is null. And so those are a few helper methods, all part of supporting ultimately the delete method, which we'll get to in the next video.